Okay, we are ready. Did everyone get a page of notes? These are our notes for today. Yep. Okay, I need everyone's attention up front, please. So, we are going to be talking about properties of exponents today. Our goal today is to be able to use the product rule and the quotient, I changed it. Product rule and power to a power rule. Yes?
What was the last question?
Oh, -10. The 2 that went outside should have multiplied by the 5. It shouldn't have stayed inside the square. Okay. So, wow, that was awesome. Let's look at number 1 together, and then I'm going to have you guys talk with your groups so you can see if you can come up with a property. So we don't know the property yet. Maybe you do know the property. Maybe you've seen it before. But if you have not, let's go old school. We do know what x squared means. What does x squared mean? X times x. Okay? And that means x cubed is? So how many do we have total? 5. So our goal is we want to figure out a shortcut. I don't want to have to write this out. What if I had x to the 10th times x to the 50th? We don't really want to write x out 50 times. So we're going to talk about it as your groups first. So hold on. So we want to skip from the beginning to the answer without having to write it out. Some of you, it looks like you already have an idea of what you think the property is. If not, talk to your group. See if you can come up with a shortcut way. Something we could do with that 2 and a 3 to make it the 5. Okay, I need your attention. Back up front. Please quiet down. So, let's have names. Why are names not working for me today? Ashley, what did your group come up with? What do you think we should do?
Just add the exponents.
Okay, add the exponent. So if that's the case, if we add 2 plus 3, we should get the correct answer. So does adding the exponent sound correct?
Yes.
So on number 2, that would give us S8. Number 3, what would we get? 12. What's different about number 4?
You have to
Chris.
You have to add the x's together and then the y's together.
Yep. Really chatty today. Right now, everyone should be quiet. I'm going to have to start moving people if we can't be quiet for notes. But what Chris said was correct. He said combine the x's together and the y's together. So we get x5, y7. You could put a times sign in between them and still be correct. Number 5 can also be a little tricky. But our rule says to only add the exponents. It doesn't say to do anything with the bases. The base stays the same. The base being the big number, the exponent being the small number. So number 5 should be 2 to the 5. You do not multiply 2 times 2. Okay, and then number 6, what should we get? X to the 6. Okay, but this x to the 0 is kind of weird. I want to find out a little bit more about x to the 0. So, nope. Well, it depends on what you mean by that. Like the entire thing, yes. Just the 0. You said just the 0, so that threw me off. But if you mean the entire thing, then yes. Okay. So let's write this the old school way really quick. If we have x squared, we have x times x. If we have x to the 4th, we have x times x times x times x Then we have this blank spot for x to the 0. So we already have 6 of our x's. We don't need any more. So what's the only thing we could multiply by right here and not change this?
1.
1. If I multiply by anything other than 1, it changes what's going on. So then the entire thing x to the 0 is 1. Anything raised to the 0 is 1. And then we came up with our rule. If we're multiplying a to the m times a to the n, we add the exponents. So there's our 2 rules. So far, we're going to add a third one. These are the 2 rules that we're trying to focus on today. So I have a few practice problems I want to talk about. Number 9 is pretty straightforward. They all have the same base. We add the exponents. So we do 0 plus 5 plus 3. So 9, pretty straightforward, about the same as we've seen so far. There's 8. Sade, I'm going to move you to the middle table here.
Why?
You and Sophie keep talking, so I had to pick one of
We
you.
weren't even talking. I was talking to her because I was asking her a question about this.
Sade, will you please move to the middle? You'll be okay. Okay? Number 10. We have 2 variables again, but one of our variables is missing something. Okay? One of our variables is missing an exponent. What should we write here? So h has no exponent. What exponent is there but not written? 1. There's our invisible 1. So now that we know that exponent, once again, it's back to basics. Add the g's together. 5 plus 3 is 8. Add the h's together. 2 plus 1 is 3.
Put a time somewhere.
You could, but you don't have to. Okay? So you could write multiply here, but when you have 2 variables next to each other, it's assumed that there is a multiply sign, so you don't have to write it. What's different about 11? Why is that different, Chris?
So they have numbers in front of the letter.
They have numbers in front of the letters. Are those numbers going to follow this rule we just found?
No.
Why not?
Wait.
Chris thinks no, they won't follow, but why do we think that?
Wait, yeah, because we're only adding the exponent.
Okay? Change, well, are you saying yes, they follow the exponent rule, or no, they do
Yeah,
not?
they do, because we're not doing anything to them.
Okay? So we have 2 conflicting from the same person, changing his mind. Ronald, what do you think? Do you think we should add the 2 and the 5, or do something else? Do you think it follows the exponent rule or not? Okay, the b's can combine together, but right now we're trying to focus on what should we do with the 2 and 5. It looked like Andrew had an idea. You raised your hand earlier. No, you don't have an idea?
Kind of.
Okay, what do you think?
Sure add.
So he thinks we should do 2 plus 5 is 7. Sophie is saying no, I think not. What do you think, Sophie?
Leave it. Because
Okay.
it's the only one.
Okay, she thinks leave it because they're different bases. Edgar.
I just signed 2 and 5.
Okay, so we have 3 things we're thinking about. One is leave it, one is actually multiplying, and one is adding. So we have 3 different arguments for what we should be doing. Okay. So let's go back to our rule that we found today. what is the rule specifically talking about? When we're multiplying, what kind of numbers do we add? The exponents that are integers, but the exponents are 2 and 5 exponents. What just happened? There we go. Are 2 and 5 exponents? No. So we can't apply the adding rule. We've eliminated one. We say, okay, we can't do this because they're not exponents. They don't follow the same rules as exponents. Okay? So one person said leave it, and one person said multiply it out. What does this look like?
Multiplication.
If we leave it, it looks like multiplication, which would give us 10 anyway. So multiplying it out is the correct thing we should be doing. Yes, they have different bases, but if I just said multiply 2 times 5, you'd know what to do, 10. There just happens to be a whole bunch of stuff in between. So we should multiply these numbers out front to make 10. Okay. Then we combine anything that will combine. Ronald earlier said, well, let's combine the B's. What about the A's?
There's no 2 B's.
The only one. We leave it. And then what about 12? What makes 12 different? Aaron? There's fractions. We have some fractions involved now. That makes things different. I think we're going to have to split up Daniel and Trevor. You guys keep talking a lot.
Looking at you.
Calm down.
Looking at you and saying I hate
It's okay.
All they said.
Calm down. Daniel, will you
No,
please
one more
move to the
chance.
back table? No. Just move to the back table. If you guys are good, maybe next time I'll leave you. But today you need to move.
I wasn't even talking.
It'll be okay. You can survive apart for one day. I know it breaks your heart to be apart from Daniel, but you'll survive for just this 40 minutes.
I don't even know.
I'm making a joke. Alright, okay, so 4 has nothing to multiply by. We leave it as a 4. Now we have 2 different x's. We have x to the 1/2. What exponent is this x being raised to? 1. So the rule said, even if they're fractions, it said to add. We add 1/2 plus 1. Okay? That's 1.5, but I want this in improper fraction form. I don't want a mixed number. I don't want the big number next to a fraction.
2 over b.
Okay?
Which is a
So, you're jumping ahead. First we have to make this a fraction. What can we make? 1.
2.
And then we have to find a common denominator.
2.
2. So I have to multiply this side by 2 over 2, so I have a common denominator. So now I have 1/2 plus 2 over 2. Silky, I think I'm going to move you as well. When you move to the front table.
Okay.
Keep hearing noise from that direction.
Somebody's over there too.
So when I add, what do I add together?
The cross.
The 1
And the 2.
and the 2. We add the numerators together. And we leave the denominators alone. So we get x to the 3/2. What about the y? What should we do with that? Leave it. Didn't have anything to combine with, so we leave it y to the 2/3. So even if there are fractions involved, we still do the same thing. If it's multiplying, we add. So now we need a second rule to cover a different situation. The first page we were multiplying only. What are we doing differently on this? What's different about these?
You think I could scoot this like right there so I can see?
Sure. Okay, what's different about number 1 from the problems on the first page? Ashley? We have some parentheses involved. So, we don't have a rule yet for parentheses. We need a new rule. Once again, let's go old school first. Old school says, I know what squared means. What does squared tell us to do? Times something by itself 2 times. So we have x cubed times x cubed. Well, now I'm in a situation I know how to deal with. We came up with a rule for multiplying. What should I do with the exponents when I'm multiplying? Add. So we know this becomes x to the 6th. So this time I'm not going to have you talk in your groups. Just yell out what you think the rule will be. What's a shortcut? Okay, Edgar thinks times. So let's check it out. If I have 3 and 2 and I want to get to 6, if I multiply 3 times 2, do I make it to 6?
Yes.
Yes. So it looks like times is correct. So that means on this next one, all I have to do is multiply 3 times 3. But now we run into a situation that's a little bit different. What's different about 15?
There's no number with the S.
Parentheses.
Okay? We had parentheses in 13 and 14.
There's no number with the S.
There's no number with the ST. What else is different? That's one thing.
There's only one exponent.
Okay, there's only one exponent. And there's 2 of something. There's 2 variables this time. But when we looked at the variable, we know that every variable has an exponent already. What exponent do we have for S? 1. What exponent do we have for T?
1.
1. So if up above we multiplied the 2 times the 3, what do you think we're going to do when we have 2 numbers inside and only 1 outside?
You're going to multiply to the inside.
Both of them.
Times them
Both.
both.
Yeah.
Okay. Multiply both. I heard Zach say it and Silky say it. We multiply both of them by 3. So we would have S cubed T cubed multiplied by both. 16 and 17 are quite a bit like 18, so let's skip to 18. Now we have something different because we have a number in front, 4. Once again, 4 is not an exponent. It's not going to follow the rule where we multiply. We can't just multiply 4 times 3. It doesn't follow the property of exponents. But 4 does have its own exponent. What exponent is on 4? 1. Sade? Can you put your cell phone away?
That was very
Next time
cool
I'm
of
gonna
you.
take it.
That was lenient. I like that.
So we have a 1 on the 4, a 2 on the D, and we still multiply, but we only multiply by the exponent. We don't multiply 4 times 3, we multiply the 1 that's the exponent to the 4 times 3. So that would give us 4 cubed, D to the 6th, because D had a 2, so 2 times 3. And now, when we're working with numbers, I know how to solve for 4 cubed. If you can, I want you to. So if it's a number, I want you to actually multiply it out. We know 4 cubed means 4 times 4 times 4. What is that?
60.
That would be if you're adding, multiplying, 64.
6.
I almost just wrote 12 because that was what was stuck in my mind. Like, wait a minute. Okay, so now we have another rule. We have a rule for a to the m to the n. Which is multiply. So 4 cubed means 4 times 4 times 4. And 4 times 4 is 16. 16 times 4 is 64. So you're just actually multiplying it out when it is a number.
Is that the answer?
This one here is the answer. Good question. So we have one rule. If we have parentheses, we know we multiply the exponents. And if we have two things in parentheses, we know they both get the exponent outside. So here's a couple more rules that we'll be using on the assignment today. I should have cut question 20 out. It's the same as one of the questions on the front side, so we're going to skip 20. So we just want to talk about 23 and 24 now. I want to talk about these two questions and then we'll be done with notes.
Is that a 9? Right next to the fence.
There's an A.
Right there.
These are all A's.
I get it.
I can tell that one on the left.
A's, not 9. I can tell. Sometimes my handwriting's bad, but they might look like 9s, but... Okay, so 2 more questions we're going to talk about, and then I'll hand out the assignment and you can get started. Question 23. We're going to skip 21 and 22. They're similar to the ones we've already talked about. 23, we're working with a fraction again. Chance, Daniel. We're working with a fraction again, and this time we need to multiply these two numbers. So now I have to know not just adding a fraction, but I need to know how to multiply my fractions. So what can I put 3 over? 1. That makes it a fraction. And when you multiply fraction, it acts differently than when you add fractions. Adding fractions, you left the bottom the same, added the numerators only. Multiplying, you multiply straight across. 3 times 1 is 3. And multiply the denominator straight across. 1 times 2 is 2. So then, that's our exponent. We need to write our final answer still. This was just kind of side work to make sure we knew how to multiply fractions together. So our final answer is a to the 3 halves. Okay, so one last question. Why do you think I wanted to talk about 24? Why is 24 different than all of the problems we've done so far? There's a lot going on. 24 has not only parentheses, but multiplication in it as well. So where do you think we start with this? Aaron?
3 and 2.
Okay, he thinks the 3 and the 2. The question is why? Why would he pick that? That's right. Okay. Do you guys remember your order of operations?
Isn't parentheses first?
Parentheses first, but you had to do anything inside parentheses first. Okay. So inside the parentheses, I can simplify a whole lot of stuff. Inside the parentheses, 3 times 2 is 6. Then I can work with the p's. I can simplify still more inside the parentheses. What should I do with the exponents on the p's?
Yeah, don't you do exponents first? Parentheses, which is everything in
Parentheses
between, right? And then
inside the exponents. Sorry, I said that totally wrong. That came out way wrong. So parentheses. Anything inside the parentheses is what parentheses means to do first. You have to do anything you can simplify inside parentheses first.
What was the joke?
And inside, I didn't make a joke, I just said anything inside the exponents instead of anything inside the parentheses. So these are actually the p to the 2/3 and the p to the 1/3, even though they contain exponents. The math we're actually doing with it is the multiply. So really, inside the parentheses, everything we work with is multiply. So we can do them in any order since it's all multiplied. So next we work with p to the 2/3, p to the 1/3. What do I do with the exponents there? Add them. Our rule said if we're multiplying, remember we're ignoring this outside stuff for now. It's not going to go away forever, but for now, We're just focusing on the inside stuff, and the inside stuff says if we're multiplying, we add the exponents. Luckily for us, they already have a common denominator. What do we get if we add? 3 over 3, which is
1.
1. So we have p to the first. What about q? Q to the fifth. We add the 4, plus the other q has the invisible 1. So q to the fifth. And we still have the squared outside. So after you've simplified anything inside parentheses, now you need to get rid of the parentheses. But when we get rid of parentheses, everything inside should have an exponent. What's missing an exponent right now? 6. And what exponent should it have? 1. So now we multiply the outside number by every exponent inside. We would get 6 squared, p squared, q to the 10th. But I wanted you guys to go one step further if a situation like this came up. What else should I change? 6 squared is 36, because 6 squared is 6 times 6, which equals 36. So on your homework, I want to warn you, I didn't put them in any particular order. Sometimes you'll be doing the multiplication rule, sometimes the power rule, the parenthesis rule. Sometimes I even put some problems from last time on. Sometimes I'll be asking you to simplify a radical or to add radicals. So watch out. Make sure you know the order.